Right, good everyone. So now we are going to look at overvoltage and overcurrent protection of semiconductor devices. All right. So now our semiconductor device, let's say things like this IGBT. Now, if there is an overvoltage, a transient, okay, when this is turned on, going through here, it might destroy our switch. It might destroy that semiconductor devices. So we need to look for a way of protecting these devices from any overvoltage. Okay, so we'll start first with overvoltage protection. Now, there are two methods, okay, two components that we can use to protect our semiconductor devices from impact of overvoltage. The first one is the use of selenium diode. Selenium diode. And then number two is the use of varistors. Varistors. Okay, I'm going to explain varistors. It's like variable resistor, but okay, metal, and this is these varistors we call them metal oxide varistor. Okay, now the selenium diode or this varistor can be used to protect this semiconductor device against transient overvoltage and also against high DVDT. Okay, because since this is switching very fast on and off, okay. Now, if there's any transient, it might damage this switch, so we need to use this or that to protect that from any overvoltage. So what we do, okay, for that protection, we just need to, okay, the selenium diode, okay, looks like this. It's just a diode. Okay, normal diode. So we can connect this here. Right. So we connect it across the transistor or across the conductor, the semiconductor device that we are going to protect. Do you know how this works? Now, it works in such a way that the current increases with overvoltage. Now, if there is, under normal circumstances, okay, this has the same characteristics like that of a diode, but just with a small difference. It has something that looks like that. That's the characteristics of a Zener diode or a selenium diode. Now, when this is forward biased, that the forward break overvoltage of this diode is very low, you know, when it is forward biased. Now, but it has a comparatively higher reverse breakdown voltage for you to break this down. So that under normal circumstances, when normal current flows through here, when this is on, okay, current will flow through there like that, out. Because this is reverse biased. Okay? But when there is an overvoltage, when overvoltage appears here, all right, when overvoltage appears, this semiconductor device, now this diode is going to operate. Overvoltage, so this diode is going to operate. So this is the operating point of that diode. So it's going to operate, it's going to break this down. Okay? So as selenium diode operates, then the voltage across it remains constant, but the current increases because now the current has to, this will look like a short, so the current has to flow because it's going to break down this. Okay? So that is what we have here. The voltage might remain the same if I have the IV characteristics. The voltage might remain the same, but the current shoots high. Okay, the current will increase sharply. All right, so this is one method that we can use to protect these semiconductor devices from overvoltage. And we have two types. We have the polarized one. We have polarized, and non-polarized. What do I mean by that? Now, this particular diode, this is a polarized diode. So the polarized type of diode operates only in one direction. All right? This operates only in one direction, which is this direction. When there's overvoltage, okay, this will start conducting, and therefore preventing this from being damaged. Remember, there's no reverse current. This is VCC. So, all right. Now, but now, non-polarized or unpolarized type of diode is when you take the same diode again, another one, okay, like that. So it means that this kind of diode can operate in both directions. Then we call that non-polarized. Where can we apply this? Remember that if I have a rectifier, let's say I have a rectifier, now this is a rectifier. If I can connect this to DC, this converts AC to DC. We are still going to look at rectification. Okay? Now, I can protect this rectifier from overvoltage using this non-polarized type of selenium diode. Because I know that current goes forward, backward, so, and reverse. So I need to put something like that. All right, have that. Okay, to protect this from any overvoltage from the source. So if there's any transient here, okay, it will short. It can conduct in both directions, okay, protecting that. Okay, did you get it? All right, so now, the next one is the use of varistor, which is your example is your metal oxide varistor. Metal oxide varistor. The metal here can be zinc and zinc oxide varistor. We use this in lightning protection. There's a lightning protection also, metal oxide varistors. Now, this MOVs is called a voltage dependent nonlinear resistor. What does that mean? It's voltage dependent nonlinear resistor. Now, which means that the resistance of the nonlinear resistor decreases as voltage across it increases. So this is the varistor. Now, if the voltage across this increases, the resistance is going to decrease. Okay? So how can we use that to protect this? So if I now take this out and I put that here, remember we said that the resistance is going to decrease as the voltage increases. Now look at it. If I have a circuit like this, let's have a circuit like that with this impedance and then that impedance. Let's say this is light. If it is light, if you short this, what happens? Current will no more flow through here because current likes to flow through a path of low resistance. This is a short. There's no resistance here. It's almost zero. So the current flow through here will go through here. So there will be no power. There will be no light. So when the resistance decreases, the current will always like to flow through the path of low resistance. So how do we use that concept? Here, under normal circumstances, when this is conducting, current is flowing through here, right? No problem. Now, when there is a transient over voltage, now, if this is not here, the voltage transient might destroy our switch. So we said, okay, since we know that this is a nonlinear element, that the resistance decreases as the voltage across it increases. So I'll put it here so that when the voltage here across this increases, now this will turn to a path of low resistance. The resistance will decrease. And then the current, instead of flowing through this, will now rather go through this. Therefore, protecting this. Okay? So it means that it has a characteristics that looks like this. If I put IV characteristics of this varistor, okay, as the voltage increases, the current is going to increase because the resistance will be very, very small. So it will look like this. Okay, this is the IV characteristics of this metal oxide varistor. Did you get that? So we can still use the same thing also here. We can use the metal oxide varistor here to protect this rectifier. So we just put it here. Just put that there. So I might ask you to sketch how you can use a metal oxide varistor to protect a rectifier circuit. Okay. So whether this is a DC or AC, so we use this to protect our system. Now, let's now look at overcurrent protection. Okay, so now we can protect our semiconductor devices from overcurrent by the use of fuses. So if I have that rectifier, okay, so I'm just going to put a fuse here, put a fuse there before you connect to the source. Okay, that's how I can connect. So if the current from the source into this is more than the rated current of this, so instead of this blowing, I want the fuse to blow. Okay, or I can even protect these individual diodes. So I can have like that, how to protect individual diodes. So you put this fuse in series. So this other one, you put a fuse here also in series, and then, okay, now I'm protecting individual diodes. So this could be a transistor, or a thyristor, or a diode. Now, but when you are sizing your fuse, if you want to size your fuse, please make sure that you check the current rating. The current rating of the fuse. And then you must also check the I square T rating. I square T rating of the fuse. The I square T rating of the fuse should be less than the thyristor value. Should be less than the I square T rating of the thyristor, because we don't want this to melt. We want this to melt when the current the rated current, more than rated current flows through here. We want this to melt. Okay? And you must also consider the voltage rating of your fuse. 3 things that you must take into account when you are selecting the type of fuse to use for this kind of overcurrent protection. And this kind of protection, using this, is meant for thyristors and diodes. Okay? Diodes or thyristors. Remember that this can be a diode, like as it is, or it can be a thyristor. A thyristor, which means is a controlled rectifier. Okay? Did you get that? All right? Thank you.